はい、では、時間になりましたので始めたいと思い
It
ま
is
す。
now time. We would like to begin. This is an event, HRD Next, and we will be discussing engineering organization, learning from DoD and FANG. And we have Dr. Linton Wells and Mr. Hasan Yasar as guest speakers today. I will introduce them in more detail later. There are some housekeeping announcements. If you are on Zoom, there is a language button at right bottom on the screen. Interpretation button is at the right bottom of the screen. Please select the language of your choice. And if you select a language, then there is simultaneous interpretation, and you should be able to hear English interpretation at the moment, or Japanese that I'm speaking. And if you are able to hear simultaneous interpretation, please enter into chat that you are able to indeed hear the interpreter's voice. HRD Next has invited various guests so far, and this time, this is the fifth day today, and we will be discussing engineering organization. Thank you for sending us chat, acknowledging that you're indeed able to hear interpreter's voice. On January 27, January 28, we will have a 2-day event that is at the end of January next year, and we would very much like you to participate in that event. And through chat box, we will be accepting questions. At any time, if you have a question, please send your question through chat box. Now, let me introduce the guest speakers today. First speaker is Dr. Linton Welts. He was formerly with the Department of Defense. He served as CIO, and he also served in the post of Assistant Secretary of Defense and Principal Deputy Assistant Secretary. In the United States, the military has about a 3 million strong force, and the top person is the Secretary of Defense. Secretary of Defense is at the very top of the organization, and these positions are political positions, and Assistant Secretary of Defense, Principal Deputy Assistant Secretary positions are assumed by those from the forces. This means that it is the top posts of the military, and currently he is visiting special research fellow at the National Defense University, and he is also executive advisor at George Mason University. And Dr. Welts, can you say a few words?
It's a great honor to be here. Thank you very much. I value the topic of understanding not only the importance of software development, but the importance of engineers and the human relations, human resources part of this. I look forward very much to the conversation and to the chance to talk with you today. Thank you very much.
はい、ありがとうございます。ちょっと再
Thank
び。
you. Now I will start sharing the screen once again. And let me introduce Mr. Hasan Yasar. Mr. Hasan Yasar is the second speaker. He is a technical director of ISR, Institute of Software Research at Carnegie Mellon University. I think it was in 1984 during the Cold War when Japan was at loggerhead with the Soviet Union. It was seen that software is increasingly more important. And when the US and Soviets were at loggerheads, the DoD saw the importance of software and made investments. And software research is conducted by ISR. The focus is on software research. And Mr. Yasar is serving as technical director there. And actually, we co-wrote this book, and I will mention this book later myself. But I would like to ask Mr. Yasar to say a few words.
Thank you so much, Yusika, for giving an opportunity for us. I'm really pleased to be part of that panel because I strongly believe a culture or educating the people is very, very important to achieve software engineering missions. And we are the people, we are doing the work. If you don't have a good culture environment, if you don't have a good organizational support, no matter what we do technically, we cannot achieve the success. It's very, very critical to talk about the culture, organization structures, and then educating the right workforce. Thank you.
はい、ありがとうございました。というお二
Thank
方。
you. So these are the two guest speakers we have today. Now let me once again share the screen. This is the agenda today. It's been about 5 minutes after we started. I would first like to discuss the reason why we have to question how software development engineering organization is structured. I'm Nirahara from HRD. I forgot to introduce myself. And then Dr. Welts will speak under the title of Building Effective Engineering Organizations and Culture in Changing Times, the Critical Role of HR. And then Mr. Yasar will speak under the title of DevSecOps Culture and Overview and Organizational Structure. And we believe we will have 20 to 30 minutes at the end for Q&A and discussion. But please send your question at any time throughout this session today. It is a rare occasion to be able to engage in a dialogue with a person who was at the top of the DoD organization. And I understand that any question is welcome today. And please send in your questions and comments using chat box. And if you share your comment with everyone on the chat box, you will be able to see, you will be able to allow others to see what your comment is. And I will check the chat box throughout the session, and sometimes I might stop and ask a question. And of course, we will be taking questions during the Q&A session. Now, I would like to spend the next 15 minutes to present this initial presentation. Why are we discussing engineering organization today? Engineering organization is very important. Effective structuring of engineering organization is very important, and that will be touched upon by Dr. Wells and Mr. Yasar. And why do we have to think about engineering organization now? And for human resources development for HRD and for corporate management, why is it important to think about engineering organizations? I would like to first set a stage for today's session. And this is my part of the presentation. This is the world top ranking in market cap. And I think this is something that is familiar to all of you. This is the top 10 in market cap. Berkshire Hathaway and Saudi Aramco are financial service company and oil company respectively, and others, NVIDIA and TSMC, these are semiconductor companies, manufacturers, and others are FANGs and Tesla, and these are software service companies. Software service are the core business of these companies. In case of Apple, Apple does produce hardware such as iPhone, but it also develops operating software and iTunes and music that runs on that platform as well. So it develops software, provides software, and Microsoft also has Teams and Microsoft Office 365 and Google web search. It will allow everyone to be able to see information. So this is also software information service. Amazon likewise. And Tesla is a car company, but Tesla is also continuing to update software that runs on the car even after a car is purchased by a consumer. And Facebook is also a software service company. NVIDIA is a semiconductor company, but it's producing AI chips. To run AI, it produces chips as well as software. So these top ranking companies are at the core of the software service industry. Currently, the source of wealth are coming from these software services. Now, I would like to compare Toyota and Tesla. This is a comparison of market cap. Lower line is Toyota and the top line is Tesla. After Tesla overtook Toyota, it is currently about 5 times more valued than Toyota, $1.2 trillion, and Toyota is about 30 trillion yen or $0.3 trillion. So Tesla is about 5 times more valued than Toyota in market cap. But Toyota is selling 10 times more cars, and net profit is about 4 times as much as Tesla. Why is Tesla enjoying higher market cap, although Toyota is making greater profit? Of course, there is an expectations about electric vehicles, but according to Nikkei, there is a revenue including software billing, and that is a huge difference in the business model between the two companies, and that is why there is a huge expectations from the investors. They have different value chains. In case of Toyota, it starts with R&D and manufactures products and sell products, and that is the end of the value chain. And Tesla also covers the same scope of value chain. And after that part, software update continues. And if hurricane is nearing Florida, then software updates will be freely distributed to increase battery charge. Even after sales takes place, car can be updated, new autopilot software is distributed, or bugs are fixed. That is the huge difference between Toyota and Tesla. The cars, Toyota cars that are running on the streets may have had the latest software when they were sold 10 years ago, but Tesla continues to update software.
So
Toyota also updates the cars as well, but there is a big difference between Toyota and Tesla. So value added functionality constantly changes when it comes to Tesla, and that could be the reason why there is a huge difference in terms of the market cap between the two companies. So software is important. About 10 years ago, Andreessen Horowitz, Mark Andreessen, he established Netscape, which is an internet browser, in the first place and did an IPO at the age of 23 back in 95. He became an investor after that, and on Groupon, Twitter, Facebook, LinkedIn, he was an initial investor in these companies. And about 10 years ago, he contributed an article to Wall Street Journal and said that currently, both technologically and economically, there were major changes taking place, and software companies were trying to dominate a major part of the economy. And 10 years have passed since then. And he was saying that many industries would be disrupted by software, and there would be many new companies in Silicon Valley in charge of such a disruption. And these Silicon Valley companies have been disrupting established companies. So this indeed happened within the 10 years since he made this comment. So people knew about this 10 years ago, but in reality, this is really happening. Now we are saying software and software without providing an explanation. So what are we talking about exactly? So first of all, hardware. To operate the system, hardware is necessary. For example, my PC here or my iPhone, this is a Fugaku supercomputer or servers and so on. So hardware is the physical devices that operate the systems. And then on top of them, there is some Windows, iOS, Linux, and so on. And we have a Google Chrome, Line, Microsoft applications, and then there are some external internet web services, YouTube, Amazon, Yahoo, for example. So software is which part? OS application. To use Google, software service created by Google is accessed through the web. So that is what software is. So this is an important point. So now hardware and servers and so on, infrastructure as a code exists. So as software, if you write a code on the cloud, you can use the servers on YouTube and Amazon and so on. Quite a few servers can be established quite quickly. So in the past, you had to get devices and you had to set them up and so on to start a hardware. But nowadays, as I did before, HP's server, I buy it first, and then in 3 months' time it arrives, and then you have to set it up. So it takes a lot of time. But now on the cloud service, as long as you can move the script services, and the server can be set up within 10 minutes or so. We live in such times. So infrastructure code, some sample code, it looks like this. So you don't have to understand what this code is saying exactly, but it says which region or which server, Tokyo region server, or is it North American server or Singapore server? You pick a server and then do all sorts of configurations. So you can see such codes. So these codes can be reused again and again. Once you create it, you can apply it to some other place. You can set up a server in a couple of minutes time. Something new can be created. So setting up a server or getting hardware is being automated currently. Now, Google or GAFA, FANG, and Tesla, their source of strength is software services. As I said earlier, but continuous improvements and updates, once you set things up automatically, and then there is automated updates, that is the source of wealth for them. For example, in case of Google, 45,000 commits per workday. So on a one workday, 45,000 changes are implemented. So they're doing a lot of things behind the scenes. Number of developers, they have more than 30,000 developers at Google, and they do 45,000 changes. So 1.5 changes per engineer per day. And on the right-hand side, it says 150 million test cases run per day. So this is operated every day. So to release a new functionality, you have to test it. So 150 million test cases are taking place. And of course, people are not doing it. This is automated. So this is really the source of wealth for these companies. So software development and continuous updates and improvements are the source of a bigger market cap that these companies enjoy. Now, Google talks about performance types in terms of software development. So what sort of engineering organization is a good, excellent organization? You can see the classification. So what sort of matrix do they use? A deployment frequency, for example. What is the frequency on demand as necessary multiple times per day? If they are doing that, they are like an elite organization. And if it's within a week or a month, it is a high-level organization. Once in half a year, they don't even update, then that's low. So what about lead time? If it's an hour, it's elite. And if it takes more than 6 months, that's low. Time to restore a service. If there are any failures or issues, how much time do they need to restore the service? So if they can restore the service within an hour, that's an elite organization. And also there is a change failure rate. You implement a change, but if there is a mistake, you have to rectify that. And then what is the percentage of such an errors? If it's less than 15%, then you'd be considered as an elite organization. So Mizuho Bank recently had some system issues and so on, such as failures, deployment, frequency. Japanese mega banks, they can only implement major changes during the Golden Week holiday as well as at the end of the year. So they are probably around the medium. And also NTT Docomo and Mizuho had some failures recently, and they took more than 1 day to restore the services. So it's between 1 day and 1 week. So they are considered a medium organization. Facebook was suspended for a couple of hours, but it was less than 1 day. And Tokyo Stock Exchange last year had a system failure for about a day, and they couldn't open the market. And that was restored less than 1 day. The next day, they were able to start the service again, so they were considered as a high organization. So if you take more than 6 months to restore the services, you'd be considered as a level low organization. GAFA and so on. Facebook is in the high category, but they belong to the elite category, such as Tesla. But Japanese companies, they have a room for growth going forward. Now, 45,000 changes and improvements per day. How do they realize those? Automation is the answer. So development process is automated. CI, CD will be mentioned quite a lot today. So please remember these words. If you speak to an engineer, you can ask questions such as, are you doing CI or CD? And then they would be quite impressed. So please do remember these words and try to use them. So continuous integration and continuous delivery or deployment is what CI and CD stand for. So programmers create a code and they are automatically tested and then they are automatically deployed. Traditional process was reliant on manual processes, but these processes have been automated. So software development methodology history during 1970s, waterfall was the idea. So Mizuho Bank system was created or built by a waterfall approach. So you go from top to a bottom, and this is quite similar to construction process. So once you design something, you cannot really go back. That is not really assumed that you go back. So once you build something, it is a correct specification. So specification changes are not really necessary. So these are the assumptions in terms of this design philosophy. So a lot of things are dependent on manual operation. So since 2001, with the advent of the internet, so agile software development declaration is on the slide. So rather than writing many documents, you should create an operational software. So rather than trying to have a good negotiation in terms of contracts, you should collaborate with customers. Rather than obsessing about the original plans, you try to respond to changing needs of customers. This is really thanks to the advent of the internet. And after that, once a system is operational on a live environment, you use a YouTube, but if there are continuous improvements on a daily basis, you have to update on a daily basis. That means development has to happen along with the operation and vice versa, and they happen all at once.
That is what is called DevOps. Development, dev, and ops operations are integrated, and this is thorough automation. And from around 2015, or slightly before that time, cybersecurity became a serious issue. And DevOps, in addition to DevOps, security is also integrated, and all of these are automated. And what Hasan-san will be speaking today is this DevSecOps. And the co-authored book is also a first ever book, I think, in Japan on DevSecOps. Why the change? As I mentioned earlier, in the 1970s, there were ERP software, and up to 2000s, back office operations were made more efficient with software. Specifications did not change. And with a waterfall method, software was developed, and there was not much upgrade. When accounting system was developed, then the upgrade maybe 3 years from the initial deployment when tax system is changed. But now when things are deployed online, on internet, agile development is necessary, agile deployment is necessary. And so agile development and then DevOps and security threat has become serious. So DevSecOps and with AI used in full-fledged fashion, MLSecOps, machine learning security in addition to DevSecOps. And I'm running out of time, so I will speed up. Typical DevOps and DevSecOps system architectures are shown. Monolithic, monotonous architecture, and there's an architecture based on microservices. Waterfall types are traditionally monolithic architecture. The screen that people use, the user interface, is operated on the back end, and that there is a storage of data that was processed, and all of these are developed as a package. On the other hand, in case of microservice architecture, UI backend database are divided into smaller components. And small circle, this may be for customer management, that this may be for point control, and this may be for payment, and this may be for linkage with outside. And small groups are created, and API at the center will be connecting all of these microservices. And DevOps and DevSecOps typically take microservice system architecture. With microservice system architecture, the benefit of that is that the unit of development can be made as small as possible. Google may have 40,000, 50,000 people in one UI team, one backend team. Then it will be 10,000 strong team. That will be too cumbersome. So within a UI, there can be a small microservice management team, and that team can think about the task that they have to carry out in the language of their choice, in the way that they like, and then communicate with the rest of the teams. So that is the architecture and team structure. And two pizza rule is Amazon rule. Team has to be small enough that two pizza would suffice. I think that means about 5 to 10 member team. And that architecture is efficient way to form engineering organization. Mr. Inamori coined the term amoeba management in Japan, and I think it may be a similar concept. And Amazon and Netflix have a huge number of microservices, several hundreds and several thousands of microservices, and one of each of them is a team, and there's a high-speed operation, and without minding about other teams, each team is focused on adding new development, new function, and that is called independent deployability, and that is ensured to allow for speedy implementation. This improvement and development, and to develop improvements can be traced back to Toyota production system. Japanese car manufacturers became dominant in the world, and they may be also still dominant today, although there is also a rising presence of Tesla, but a lean production system was adopted by Japanese auto manufacturers, and that was introduced in 1990 by MIT professor. And this is how Japanese manufacturing industry is structured, was shown, and that is also adopted in DevOps. And there is a book, Accelerate, and the source can be traced back to Toyota production system, which is now adopted by the FANGs. And so the Japanese system, what was originally Japanese system, was adopted, if you will. And what Toyota is trying to improve is this manufacturing part. Tesla has manufacturing, but it is also doing improvement in software updates. And therefore, if improvement in software update is adopted in Japan, Japanese companies can become stronger once again. And that is also some of the topics that I discussed in this book. This book will be published tomorrow, and it is also advertised in TV, and there is a 50-page section at the end by Mr. Yasar, which is quite academic and high-quality content. And about AI, I have written a book on AI, and I understand that Chinese language translation will be published soon. If you would like to understand more about DevSecOps, if there are engineers, Hasan-san and Dr. Wells and senior officials from the METI and members of the parliament will be speaking at that event. So please do take part. I think I spent more than the time I was allocated. So the conclusion is software development capability is the source of competitiveness of the corporate sector today, and it's also true in national defense. And what is key is to be able to have software improvement cycle that is very speedy. Therefore, CI/CD automation and microservice architecture have become a trend effective method. And security also has to be considered. So development method is now DevSecOps. In order to improve efficiency of engineering organization, we have to start with architecture and development methodology. And on top of that, growth-oriented culture, engineers' mindset, and sharing of long-term objective are important. Japanese companies and the Japanese government should practice Toyota style improvement in software development. So that is what I would like to argue. And regarding Toyota production system, what is the source of or origin of Toyota production system? And I read a book by Mr. Taichi Ono on Toyota production system. And erroneous understanding leads to lower efficiency. And with erroneous perception, this T line is comprised of same length of line, but oftentimes people are tricked to see that the vertical line is longer than horizontal line. And unless a measurement is taken, it is not possible to understand that two lines are of the same length. And so improvement is possible by removing such erroneous perception. Most of the problems leading to poor efficiency are caused by these erroneous perceptions. And that is what this book by Mr. Ono talks about. So we should first start by doubting whether we have erroneous perceptions. I have spent fully the 20 minutes that was allocated to me and even more, but I think we have ample time today. So I would like to pass the microphone over to Dr. Welts, and I will be sharing the screen. And questions are welcome at any time throughout the session.
Thank you, Nirahara-san. Is the screen now being shared?
今私の方で画面共有させていただきま
Yes,
す。
I'm sharing the screen on my end.
Dr. Wells,
Yes,
do you see my screen?
I see your screen.
Okay. So go ahead.
So today I would like to talk about particularly the critical role of human resources, which perhaps many people don't think about in building effective engineering organizations or software development, but really is very, very important in these times of changing cultures and technologies. Next slide, please. I'll talk about four things. The first is the concept of resilience and why it's important, what it is, and again, the critical role of HR. Then some of the technology changes in high-speed internet, fifth generation wireless, and then Japan Society 5.0. Cyber physical systems, which is to say systems that link physical systems like generators and pumps with the internet. That, of course, is a large part of the so-called Internet of Things. And then finally, the role of DevSecOps and IT leadership and why HR becomes an important, essential item for cross-cutting support in these kind of environments. Next slide, please. So what is resilience? Resilience is the combination of coping capacity and adaptability. And I owe this formulation to Dr. Lees Miller-Hooks from George Mason. The U.S. National Institute for Standards and Technology recognizes four phases of resilience: to anticipate a crisis, withstand it, recover, and then adapt to the new situations after the crisis. This includes two critical concepts. One is organizational capacity. Resilience is not a plan. It's not a strategy. It's not a milestone. You have to build the capacity over time within the organization. The second point is the ability to adapt and grow. And the net result of this is to be prepared not to bounce back to where you were, but bounce forward better. Next slide, please. This is a graph. If you look on the left of where the normal performance was before the disruption, you look over to the right, you'll see that the goal is to wind up with a better new normal, a stronger afterwards. And you can see down at the bottom the phases of anticipate, withstand, recover, and adapt. So this is graphic resilience. Again, it's preparing to bounce forward better, not just bouncing back. Next slide, please. There's a misunderstanding sometimes between security and resilience. Security is actually locking up and sort of hunkering down, trying to keep bad things from happening. Resilience, on the other hand, understands that bad things are going to happen. And so the goal is, how do you achieve the organization's goals under any level of shock or stress while fighting back and emerging stronger? That's the difference between security and resilience. Next slide. Resilience is a core leadership function, and it must be built at all levels. The leaders have to encourage resilience among the people, and they must treat this as a core characteristics of the business to be nurtured and be made sustainable across changes in leadership and changes in organization and culture. Treat this as a positive business aspect, just as Hasan talked about the importance of software and the importance of intangible assets. This is a positive business asset, should be resourced accordingly. And the idea is to build an enduring organizational capacity for resilience. Next slide. There are three kinds of resilience. There's a cultural resilience. Is the organization willing to fight back? This is based on a foundation of ethics and principles and governance. For example, if you have a problem, if you have, say, a cybersecurity breach, is the response of leadership to try to hide it and cover it up and keep people from knowing about it? Or do you recognize that this is a problem we have to address, we have to solve, and use it as a lesson to improve the way business is done to avoid future problems? There's operational resilience, and that is, are your networks and your telecommunication systems resilient? Can they deliver the core internal and external messages that you'll need to keep operating? Do you have the financial resources to make it through the crisis? And finally, there's infrastructural resilience. The essential services, can they be sustained? Power, water, energy, communications. And do you understand the growing interdependencies among the infrastructures? There are no easy answers. There's no silver bullet for this. Persistence is essential. It may take many years and several iterations to get it right, but it's absolutely critical to develop this kind of capacity within the organization. Next slide, please. The final point of resilience is that concerns cyber resilience. The cyber resilient organization has got to be part of an organization that itself is resilient overall. So cybersecurity contributes to cyber resilience, but cyber resilience is much broader, just as the resilience of the organization overall is much broader than the cyber resilience. And you have to address more than just technical cyber issues. The cultural and information components are key. The people are critical. And in any situation like this, the sociology will always be more important than the technology. Next slide, please. So turning to some of the pending technological changes, we have coming high-speed internet, 5G, Society 5.0, and this, of course, will affect how things interconnect, machines, devices, objects, people. It would be driven by the 5G wireless, 5th generation, continuing growth of fiber, the explosion of the Internet of Things, internet coming from low Earth orbit satellites. They're even beginning to plan for 6th generation wireless. And this, of course, is the basis, all these things, for Japan Society 5.0 or Digital Japan. Again, tech alone is never the answer. You have to tie together people and processes and organizations and technology. And this is why leaders will have to balance policy, resources, and people excuse me, against rapidly changing technology. Next slide, please. Thinking of the velocity of technological change, if some factor, for example, computing power per unit cost, doubles about every 18 months, In 5 years, the increase will be about 900%. But in 10 years, it's 10,000%. And in 15 years, it's 100,000%. Now that curve may accelerate, it may slow down, there may be some kind of step function increase like quantum computing. But the point is, a linear projection from where we are today cannot work. And part of our problem is so much of our budgeting, planning, and other things assume linear projections rather than exponential. Next slide, please. So what this is going to do is fuse together cyberspace and physical space. And it's going to involve not just technologies, but also industries, social activities. And it's got to cross different sectors and cultures to foster innovation and interoperability. In this environment, HR will be key to helping leaders bridge these stovepipes and match the workers' technical skills to society's emerging needs. Think of just 4 areas: medical change, energy, agriculture, food delivery, manufacturing value change. In each sector, the software will link bottom-up inputs to the cloud, but the context and the cultures are very, very different. Next slide, please. I'd like to talk a little bit about cyber physical systems. These are growing in importance, and it's where computing capabilities and controls, operating controls, are integrated with physical capabilities. These are needed for smart power grids, the ubiquitous Internet of Things, autonomy, autonomous vehicles, for example, and even remote surgery via advanced wireless channels. The IoT, with all its explosive growth, is one form of cyber physical systems. So these are literally going to be everywhere. And as they become ubiquitous and essential, they're going to need to be resilient. But this poses particularly difficult management and security challenges. We have to merge operational technology like generators, pumps, and actuators with information technology, so OT and IT. These have very, very large cyber attack surfaces, and the interdependencies are poorly understood, and the attacks on them are increasing. The pace of tech change is very different between the OT and the IT. There's little physical counterpart to, for example, how generator development changes to the kind of agile DevSecOps spirals that Hasan talked about and that we'll hear about next. So effectively integrating IT and OT is hard. The stakeholder engagement on both sides, the people, is at least as important as any technology, and it's going to require continuous and comprehensive organizational learning. It's not enough to put a system in place and have it stagnate. You have to be learning continuously. And again, this is a case where HR can provide really important support to leaders. Going back to the cultural difference between OT and IT, for example, if a generator goes down, the technician is likely to reach for a wrench or electrical device rather than looking for a cyber solution. The leaders have to understand the personalities of their employees. And again, HR can help. Next slide, please. So this is a challenge for leadership. Dr. Yasar will talk about this. DevSecOps requires communications and leadership and teamwork within a framework of the organizational culture and the rapidly changing tech. The question is, how do you keep track of the big picture while executing diverse details? The HR can help match skills to tasks. Lifelong learning is going to be essential to stay current. It's not enough to have a degree from a university from 10, 15 years ago. You have to find ways to stay current. The leaders must address the interfaces between the OT and the IT. And security is going to be absolutely key to security. One of the things that concerns me is as Japan builds out Society 5.0, it's being built essentially on an insecure foundation of the Internet of Things. It's important that technology managers learn the language of the boardroom. They have to describe their solutions so they're of interest to decision makers. These tech issues are not tech issues just for the chief information officers or the tech team leaders or the specialists. The forces of IT, DevSecOps, OT are what determine the winners and losers in economies, the relations among nations, even how our children are thinking. These are issues for chief executive officers and ambassadors and policymakers, and the military for the commanders, not for the specialists. In addition, these are what are termed wicked or complex problems. There are always groups of different problems tied together. And so the solutions will almost always be iterative. You will never get the right answer the first time. And so it's important to plan for periodic reviews and adjust your, if need be. And this is a formidable leadership challenge, both with your seniors and your subordinates, because you have to tell them we may have to change. And this is not a sign of weakness. This is a sign of strength that it's based on a review of what's happening. But that's a hard sell. Again, HR can make major contributions to the success of the project by helping leaders understand the personal, the people dimensions of this. Next slide. Thank you very much. I'd be more than happy to take questions either now or during the Q&A later on. It's been a pleasure being here. Thank you.
はい、ウェルズ先生、ありがとうございました。
Thank you very much, Dr. Wells. So if you have any questions, please send your questions in the chat function. So a Japanese defense minister should listen to your talk, I would say. It was a very interesting presentation. By the way, for your information, resilience talked about by Dr. Wells, bounce forward better and so on. Myself and Hasan-san wrote this book, and there is actually a mention about that. So resilience and DevSecOps are the main topic of this book. So how to make money through software development. And that is also another point written in this book. So there is one chapter almost dedicated to the contents provided by Dr. Wells. This is easy to understand book for Japanese audience, I would say. Well, thank you very much. So before moving on to the Q&A session, I would like to give the floor to Hasan-san, how to create a DevSecOps culture. So that will be the topic by Dr. Hasan, please.
Thank you so much, Shinohara. And I'm sure you're going to share this slide, right?
Wait a minute. Yeah. Just a moment.
So while Narahara is waiting to get the slides, and we really talk about the great content so far. We're just going to cover up the DevSecOps culture and organizational structure and overview. So how are we going to achieve all the successful organization structures and culture in the modern development lifecycle? As Narahara said, the beginning of the session, and Google or the Netflix or the Facebook or any software organization companies are doing very well, and they are delivering a software capability so fast. They are doing very agile style. But we have to look at what is really behind the scene. We're always thinking about the technology. We're always looking for the software as the code and program. But most important factor of this organization is actually structure and their culture. That's how they're getting very, very successful. Let's go to the next slide, Narahara. Yeah, and you can skip this one. So we have the intro we had at the beginning. So I would like to save a time. So when we look at the software modernization and culture, why process and technology people are related to each other? As I said, we always look at the software world, but there is a balance in between. Like we need the technology, so we can really see how we are doing well. We can use the kind of software, or we can use any type of application or a program. Yeah, we have to do our job. But we need other elements, which is like, how are we accessing all this complex environment? How are we writing a software? What techniques are, what the practices are? It's very processed. Like we need to know how we are communicating in between. Like how we're going to know what type of technology in terms of the process we are using it, what type of techniques we're going to use. So kind of a common understanding of our communications and with respect to the software that we are building or the system that we are building. So we should have a common understanding with the kind of how are we going to use continuous integration, as Narora said, like how are we going to build up the structure for writing the code, communicating each other. So when we look at these two elements, technology process, we are dealing with the people. So we are the consumer or a pure producer of the system that we are building, which is a workforce, which is the people, right? So Google or Facebook, all this high organization, in terms of the performance organization, are doing very well because they have a skilled workforce. They have our competent people are working to carry out the organizational vision and structure. Is going to cover up a lot. But the combination of these three elements, it is dominated by the organizational culture. That's what we're going to talk about today. So how are we going to build up the culture that will support the technology, process, and people that will be aligning all together? As one of the definitions, the culture is kind of representing the way of and how the people are communicating, how they're getting socially, how they're focusing, how we are getting the vision to carry out to the developer or in a very low chain organization structure. It's important that we should remember is there is a value and people are sharing amongst each other. That's kind of like how the Apple or the Google is deriving the value throughout the organizations. Okay. So let's look at a little bit complex system. Let's go to the next slide. So when we look at the kind of another perspective in the Department of Defense, which I have been heavily involved in the DevSecOps implementation. So it's really creating a very big communication environment, and also we talk about the and Dr. said as well, and previously Dr. Linton said, like, how are we going to get all the systems complexity? And we are talking to various component organizations. So in the DoD, Department of Defense, it's very complex. There is a digital engineering concept that we have been working on under the system engineering principles. And we have so many different units, different organizations, different programs are communicating each other. So when we look at this complexity, yes, there is a technology complexity in place, but however, to build up the complex structural organizational support to build up the very complex ecosystems, like missile systems and weapon systems, it is requiring a trust and a collaboration between team members. So when we say the trust, and I'm just going to open up a little security here, especially when we talk about DevSecOps perspective. Yes, stay here. So when we look at DevSecOps perspective, trust is really important elements to build up the communication with the team members. So like, do we know the team members enough skilled that we train? Do we have authoritative people in the organization? Do we have enough processes supported? So overall, all this communication is kind of build up the ecosystems on a culture around that. It's like, how are we sharing? How are we communicating? How are we measuring ourselves? Do we have a mindset to communicate and collaborate that? So why is becoming an important? What is the problem that we are trying to address? Let's go to the next slide. So when we look at the organization structure, I know a very small subset of it. Think about a very high level scale in terms of the very different organizations. So we have a development team, quality analyst, and IT operation. So in a small unit in the complex system we looked at, there are multiple units, multiple components, and dev team, operation team, quality, and analyst team. This is kind of a typical structure has been created, and I said at the beginning from the Dr. Winston Stroik's paper, 1970, which is kind of a more waterfall approach was defined. But what is important here, we have to understand that when we're creating a kind of siloed organization structure as dev team allocating, yes, you are responsible as a dev team. you're responsible as an operation team and qualitative. Even though when we have a small subsystem that we are working, then we have a kind of created a silo structure and creating a problem, how they are communicating, how they're working for their environment, because each of team member has its own incentives. Each of team member has its own way of communicate. Each of them its own process and structures. So let's say, how is that possible, right? We are an organization like a Department of Defense, or we're an organization that we have a value. Why this is happening, right? Why we, as the small unit of organizational unit, are not communicating well. Let's look at the next slide. So when we look at this perspective, yes, as an organization, we have a good positive things we have been thinking. Like we are saying, as an organization unit, we have a good documented, we have a clear communications in it, and we have a clear understanding of our objectives. But in the meantime, each of the individual team member has its own understanding. So that means what we are saying as an organizational goals, it looks like it's not reflected in a unit level, which is individual level. Or if there is no alignment between organization and policies and practices versus a team structure, or if you're not able to get the same communication in our organizational structure, then there will be a misalignment within each team members. So as we say, like we are trying to do something in a positive way, when we go into the unit and a program level or a division, there is a misalignment. So because of this communication, because of this our misunderstanding, or we don't have a clear definition of the policies and procedures in organization structure, if there is no clear policies, if there's ambiguity on the write-up, the negative is each of the individual team member, they have their own definition of the terms and alignments. And most important factors, and Dr. Linton said as well at the beginning, so our organization manages structure, if you're not able to becoming a role model for our organizations, like we are saying something, but we are not actionably presenting what we are saying, it kind of typical walk and talk concept. If we are sending a conflict message between the team members, and then as a result of this conflict messaging happening between organization units and then higher up level, so each of the dev and operation team, they are doing their own way of understanding, they are trying to build up their own way of the working, so it's creating a clash between each organization unit. So, and overall, what we have to, again, is kind of comparing each other. We can look at the organization unit and try to carry out throughout the, from end to end in organization structures. So how we are doing this concept and how it is happening in the Google or Facebook, all the very elite organization based on the Google DORA research concept, and then the paper has been published this year and a couple of years before. It's all focusing about the communicating. It's all focusing about the value of the organizations. But how are we going to measure this concept? How are we going to make sure that we are doing well when we look at the cultural perspective? Like, yes, we would like to make sure that we are addressing, but how are we going to measure this concept? Let's go to the next slide. In a typical measurement indicator for organizational structure, and then Dr. Roy Wenstrom wrote a paper about the organization structure indicator, like how are we going to measure the typical organization, how are doing well. It's very critical and sometimes very difficult to measure, because yes, we would like to see how we are doing well, but at the same time, what are the indicators and our successful an organization? Yes, maybe we have a technical indicator doing business, but are we doing the right things? And are we building up the right talented infrastructure in terms of the workforce? Are we able to build up the right capabilities in our environment? So typically, the Westrum came up a couple strong items as the indicator for the culture, like such as in my team, information is actively sought. Or are we able to learn from our failures? Are we able to get some stories from our failure and working as a team together, and then building up the solution to the as problems as a team, which is very similar to the actually originated from the Toyota CADA principles. If there is a failure in our pipeline, the production pipeline, manufacturing environment, as a team, we'll get together, find the solution. So that's kind of like carry out almost every high performance organizations. It's focused more about the learning from our failures. This is actually fundamental principles of DevOps perspective. We're going to learn from our failure. And very important, be resilient. So we have to be ready. We can learn from our failures as a team and work in the specific. So you may change your indicators in your organizations based on the 7 components. I'm looking for responsibilities, looking for cross-functional, looking for the failure scenarios, new ideas. So you should be really creating what are the possible indicators for ourselves so we can measure how are we doing well, like in terms of the communication, in terms of team perspective. Again, you can adjust this type of indicator for your work, you might be doing it, but it's very important, a couple of principles like how are doing well, and do we have a learning infrastructures in terms of our workforce? Are we able to build up the responsibilities as shared, not like one person responsible for a failure and everybody responsible for the kind of a success? It should be shared, everything else. So let's go to the next slide, and then let's see what is the relationship between an indicator between the DevSecOps thinking. So based on the studies shown at the Western culture studies and applied into the DevOps work, and based on the DORA research and then the DevOps State of Report, DevSecOps survey, we find out that high IT performance have significantly higher restaurant scores, which is the 7 indicator that we discussed in a minute ago. So what really telling us, if we are in the high IT performance, like a Google or like the Amazons, like a Netflix, they are doing well, and with respect to the learning from their failures. Actually, one thing I really like that the quote from the Elon Musk, when they submitted launched the rocket and the rocket got exploded, he said, instead of like finding the failure to the people, he said, I am so happy that I'm able to extract the data from the launch failure so I can share that data to get better. This is really a setting stage from higher level perspective. Instead of criticizing the people, said, I am happy because I learned from my mistakes. I have enough data so I can run the next launch as successful because data is going to tell it to me. This is really important. I know we don't want to do the fail in the missions if the human is involved, but this is kind of a mindset. How are we going to learn from our failures? So when we learn from our failures as a team, we are looking for a more performance-oriented culture that we have been working, right? So we're getting together and looking for together in a success of organization. Let's go to the next slide so we can dive into the more indicators. To measure these items, we have to look at it regularly. So we have to look at in our structures, in our communications, in our structure and organizational environment. We have to look at what is really good practices are we making well. Kind of we can measure the happiness. I know it's very tough to measure the happiness, but however, this type of failure, this type of team communications, or the working for the same value, so we can measure in a regular interval, like maybe the quarterly, maybe you can do every release, or maybe you can do yearly basis. But ideally, you should be aligning your measurement of your culture perspective, and possibly based on your major release, or you may be getting some sort of a deployment practices if you're an organization that you're building the software, or you maybe have some other quarterly financial release you're waking up, creating, so you can really measure the content with respect to the how are we doing well with the culture. So you can collect the data, you can really look at the structures. Are we missing something? Is there any problem in our organization unit not communicating well? Maybe you may see some communication in between, you can probably do rework, or maybe looking for the how can we rotate the team members. Another example from the Facebook perspective, and there is a kind of a production engineering concept and brought into the community. What they are doing it to understand the pain of operational infrastructures, they are rotating engineers between the dev team members every 2 years. So every engineers, they have to position, they have to work with dev team together, but their main responsible organization unit and operational, but they're working a dev team as an assignment for a given projects. Why is the 2 years kind of a reason? Because usually 6 months is about the ramp up time learning, and then 6 months is more effectiveness, and next year is kind of building up the next cohort, or the next people will come into that role so they can carry out the knowledge. So if you look at this perspective, kind of building up a learning organization structures as they go, is measuring how they are doing well and how are they communicating. Another interesting things I would like to share, which is a very, very known things. Gitlab and another example, Gitlab organization, they become $1 billion company with a short time frame. Gitlab did a single things very well when they started. They build up every communications in their team structure or team meetings. They said, whatever we do in our team structure or meetings, we have to take the notes. We have to create an objective of the meetings. We have to have a value of the meetings, but we have to store that information that everybody can share, everybody can see. So technically, they use the infrastructure as a code concept, as Nirara said at the beginning, for their meeting notes. What happened after this type of learning structure, and Gitlab is able to create thousands of pages of the notes and information in the organization structure. They build up a learning infrastructure. Everybody can learn, everybody can share, everybody can understand, everybody can really see what they are. If anybody joined the team, they are learning from their past meetings or past notes for a specific problem, specific issues, and learning from the history. That became a learning organization structure by treating every document as the code and putting the repositories. So when we look at the repositories, it became a value for them, because the value of that GitLab is more building up an organization structure as learning pieces. So kind of represent their value in their organization. They kind of measure, they watch how they are doing it, how they are changing, eventually become a great learning organization structures. Let's look at the next slide. So when we're comparing the three things like the organization structure and the culture perspective, the Western came up a topology model for this typical organization structure. If the organization is more pathological, which is more the power-oriented organizations, what are the indicators or what are the characteristics are? So in that indicators, like if I'm in a bureaucratic, like the indicators, so it depends on where you are, you may see low cooperations for the power-oriented organization. Mastery is not kind of shy, you're not able to speak up, you're not able to talk with the failures because it's kind of punished, which is more the power-oriented organization. If you are following some bureaucratic papers, like if I'm not able to get the management approval and timely, if a unit of the people not able to decide by themselves, they cannot move forward because they're waiting a decision from somebody else, which is more bureaucratic organization. But the high performance organization in DevSecOps and thinking, or the modern software environment that how the Amazon or Google does, they're more generative performance-oriented organization. So I don't want to go each of them in detail, but you can look at the screen. But specifically, I would like to call out the generative performance-oriented organization, a perfect example of this modern and engineering skills environment. It's also reflected in their architectural of their systems, like Amazon example, and Nirara shared at the beginning, like Netflix and Amazon, they have a wealth of the architecture they designed and they created, and based on the team structures, they created a pizza rule concept. What they have said, they said, you are a team, you are responsible within your team, maybe 10 people, maybe 15 people, you're gonna share the risk among your team members. You are a responsible unit, so you can achieve your goals, building up the services, and you will be responsible to build up that service. They kind of organization create a very value-focused unit team, and they are working in a high tempo, and they're communicating well, they are sharing the risk as a team members together. Let's go to the next slide. So as the overall, and what we're expecting from organization culture as a key takeaway, so we have to build up an opportunity for our team member to share the innovation. Like we can think about how we can align our values and mission in a unit level, in a program or system that we are building. We should align those. We have to support any type of incentives that comes from the team perspective. We have to motivate a team by creating a values and reward them, like simply saying a thank you for them sometimes. So in a very complex organization, it doesn't really matter as long as if you're able to follow up the common understanding value from higher level to the organization lower level, because everybody will be in the same page. More specifically, as a takeaway, one more thing that in this DevSecOps thinking, when we have a value that we are delivering, the value is impacting our organizational release. Maybe we are having a website, maybe we have a system that's serving to the human needs, something that people are happy as a result of the outcome. Another note here, which is kind of supporting a key takeaways, when we have done the DevSecOps survey, we find out that if organization unit are following the good culture, which is communicative and learning, are able to deliver the software automated fashion, and the teams are getting more happier because engineers will like to see the result. Engineers will like to see impact. And sometimes I call myself, I'm writing a code, but I'm kind of writing a plan. If my mind is clear, if I'm able to contribute it, I can get an impact to the organization that I'm part of it, so that an organization will be successful. I'm going to be part of that solution, getting incentive from that organization. Let's look at a little bit on how can we architect those type of cultures in an organizations. Let's go to the next slide. So when we create an architectural design of the culture of DevSecOps environment, there are 4 common principles. So one is we should have a mindset. What the mindset is oriented based on the value of organizational team. What is our value? The organization should be supportive every phases of life cycle, every phase of that system that we are building. We should orient the value. This is exactly what the Toyota Kata principle is. We have to understand, we have to be part of it. But as they're supporting the mindset, we should have organizational structure support, which is our human resources, which is our organization environment, which is in technologies. So we can kind of highlighting environments or the people for the behaviors, enable their surrounding structures. So we are supporting each other's, sharing same information is the Gitlab example, or the SpaceX example, sharing the errors and making more a productive way that error. Yes, well, we have to do more soft skills as mindset validation structures, but we have to create a technical competencies. We have to find out what type of skill set is important to us. While we are building up a team, we have to look at how are we looking for the tools when we go to the store. We can look at the same perspective on DevSecOps thinking or a modern software environment. We have to find out the technical competencies. If there is no, we have to educate those team members. Not everybody learning from the schools. So I have been teaching at the Carnegie Mellon universities, and I see that we are not able to teach everything at the universities. Domain is different, complexity is different, language is different, but we are teaching the common principles that an engineer can survive. But in the community of your organization, we have to help, we have to educate those people. If we spend the time and money for education, we get a lot of benefits. One example is specifically, I'm sure maybe heard about it in the past, and what is how the Microsoft trustworthy or the strike threat modeling came up as a result of the 6-month mandatory training came from the Bill Gates in 2000. As a result of the Microsoft SQL Slammer error, he kind of mandated a training for all organizations. He said, let's stop here. Let us stop here as a developer architect, build up a secure software. He spent a 6 months of time educating people. Look at where we are in the Microsoft. It's great because they are able to produce better software by spending time educating team members, educating engineers, creating an environment, which we have to do that. The fourth pillar is being an active role modeling. We have to create a leadership perspective. We have to create a team unit so we can build up a good structure for active role modeling, so we can share and we can kind of say and at the same time and do actions. As a leader, we cannot say and do not action. We have to present what we are thinking. We have to be a model. And same thing for every division level, every unit level, every engineering level. Let's go to the next slide. I know we are running out of time. I'm trying to finish up as quick as possible. Sorry about if I'm late. So we can roll out this common 4 principles in a basic example, like a quarterly basis. We can look at, we cannot change everything in one night. This is a good example. We can do maybe the quarterly basis, look at where we are as a mindset changes, like how the infrastructure support is. One quick example, I'm just gonna run one Q1 per perspective. We should start our why thinking. We usually, as an organization or the engineering organization, we always start from the what. It is wrong. We have to start why I'm going to this. If I believe the reason I'm working for a specific problem and I'll be successful. If we focus on the why, then we're gonna find out the solutions. Why I'm doing it? What is the reasons? And if I know the why, I can do the how, I can do the what later on. As a parallel, we can build up a community of practice, share the information among each team members, making a hackathon as an example, making a tech talk series as an example. This is kind of another event we are sharing because this is kind of a community of interest that what we are doing right now, sharing our knowledge. It is not just me and talking. I'm going to learn from your examples most likely. Same thing for competencies. We can build up a knowledge. We can look at what is really missing. Believe me, if you look at the why, we were going to find out, okay, I know my why, but something I don't have that skills, let's learn. Let's talk about our HR, let's talk about our training departments and learn from our technical skills. And lastly, for the leadership model, we can commit our language, we can commit our values, we can carry out the life cycle perspective. So let's go to the next slide. Trying to finish up in shortly. So yeah, and when this kind of a more culture, now how are we going to structure organizations? One example of structuring our organizations is basically creating two type of positions and then roles. So a little bit background on the right-hand side, which is team topologies, and another concept on the DevSecOps communities. We can create a team based on what things that we are trying to fix about the value. So you need, maybe you have a problem. To solve that problem, you're just creating a unit of team members are focusing to solve the problem. In Amazon example, is a pizza size structure. In the Google example, maybe SREs. In the Facebook is about the production engineering. So it depends on what is your problem you're trying to solve, bring the team member together and focusing on specifically the solving that problem. Underneath of that team topology, maybe you heard about the conveyor law. And if we structure organizations, if the organization is very siloed, that will be reflected in their system they're building. So we had to get away from the conveyor law and building up the team topology concept and about the team members. So how are we going to achieve these two things and having an organization unit at the same time, we have a kind of dynamic thinking about the team structures. The concept is, let's create a job positions, but job positions should be more about the functional organizational thinking. And each of the job should have some roles that I would like to achieve, which is kind of enabling others. Let's say I may be a director, in our organizations, but my role to help others. What that really means, I'm going to help the infrastructure team, operation team, dev team to communicate that. So kind of like building up a type of structure, T-shaped structure, while I'm focusing on how I'm communicating with others, I may have a deep skills that I can achieve, which is the technical competencies. So we can build up a development team structure based on the skills that we have. And we can build up architecture elements so which is communicating each other. So every time we will evolve, we will align our roles, our skills based on what the job position says. But usually we're kind of creating a very structured organization. We are not open for learning more new skills. We have to get away those. We have to build up a more open job positions with the skills, and then we can achieve the specific example. Let's look at a couple examples here so we can wrap up the session. Let's go to the next slide. So yeah, next day, program roles. If you look at the program roles, like asking the question ourselves and creating an expectation of that role and achieving certain activities, like decision making or the skill support for the technical skills and communication perspective. And role are typically defined at the program level, like the generic roles. So we can tailor that roles to reflect the program unit that we are working on. Like what that means, we can hire kind of creating a role, we can hire a person as the team that working, but we can use that the person various unit in our organization based on what skills that they require. Which is kind of how are we creating a program roles in our organization. Let's go to the next slide. So when we're really creating a job positions, aligning with the program roles, which is organizational construct. Yes, we need to have a managerial role. We need to have a dev lead roles. We need to have probably operational lead roles, but we are creating a help for the career path for this team member while filling up the their roles and responsibilities to achieve the programs. So differences between the job position and then program roles. Job position is going to give you as the vehicle for organizational construct as being responsible, but the program role is serving the needs. So kind of like a changing your head. And as I said at the beginning, I can be an operational support to help the team member. I can support the dev team, or I can support the QA team based on what the roles I will be in the software building. So I may be a VP, but still I have a role to achieve my value. This is how it's really happening the most of the successful organization. So we have an organization of construct, but we have a responsibility to achieve our mission. That's kind of a new way of business that we have to work on. So let's combine both of them together. And as the last slide, let's go to the next slide. So when we kind of both together and filling the picture, so kind of program roles and job positions are complementing each other. So job position should not be regraded as a program role and title. Like we don't want to be creating a very structured position and disabling the support others. Or vice versa, if you're going to be focusing more at technical and role perspective and then forget our job position, will create a problem as well. So we're going to find out our relationship and measuring our culture indicators at the beginning, so we can see how are we doing well. We can create the right infrastructures with the organization, even organization structures. That's it. I'm going to stop here. So give probably a couple minutes for the questions, and I'm sure we're going to go to the QA session, right, Narara? I would like to thank you. So again, we will continue for DevSecOps days as well, and next week. In the meantime, I will hand over to you, Narara, for the questions.
Yes, yeah, Hasan, thank you very much. So I think we get some questions from I'm listening to my voice now, so hard to speak. And one question is about to Hasan, that you pointed out about the culture, and then it's not only applicable to IT organization, but also for other functions and also other industries. And then is that right understanding?
Exactly. It is for every organization. As you said, Niro, at the beginning, the software is eating the world. We may not be producing a software, but if you look at the current landscape, we are the consumers, but at the same time, and we are producing some sort of the kind of customized software for our own needs. We may be purchasing something, but end of the day, it's for everyone. It is for every organization, because as I said, it is not a typical organization, and everything has software in it. We may not be producing, but we are consumers, so we should know that the mindset. Yes, it's for every organization.
Okay, thank you. So another question is about also he or she commented about a lot about culture, and Japanese organization is more solid and hard to move to the hard to change, sometimes hesitate to change. And then his question is, let me read it. So to change the culture and to change the team, of course, the overall transformation is required. but where did it start from, and who should start from it, and then it should be top down or bottom up or such thing. What do you think, Dr. Wells? What do you think?
So,
And then Hasan, probably.
sure.
Clearly, it has to be a top down to start, but the implementation is going to have to be bottom up, in the sense the team members will have to feel they're part of a team and work together and resolve the problems. But I believe in this case, the leadership and the basic framework has got to be set from the top.
And also, do you think is the top management should change their mindset?
Well, if the top management still has a waterfall mindset or even a DevOps mindset, you'll never get here. They have to adopt the mindset of the changing world.
I see.
I completely agree with Dr. Wells. And has to be top-down changes, but implementation should be specifically from the bottom up, because the leader will be modeling to the organization change. Actually, I can give one example here and how the Microsoft changed the waterfall concept to the more DevOps structure and out under Satya Nadella. He, in the first meeting when he became a CEO of the Microsoft, he said, let's stop here. We are a team. We are a team, we are serving our customer. That's stuff from the higher level, which is the kind of a mission and vision and how the leadership is saying what needs to be done. But he kind of enabled the team, they can do their own job. So doer executors are the team members, but the leader are creating an example and creating an environment so people can be successful, which goes to the mindset organization support in our technical architecture of the culture that we taught.
I see. Thank you. 日本語で喋りますね。
I will switch to Japanese. I would like to add a couple more things. Western organization was described by Hasan, and Google adopted that, and fearless organization is the concept that Google adopted. Fearless organization is linked to performance-oriented IT organization. 2 weeks ago, fearless organization, Professor Murase of Waseda University gave lecture on that topic, and up to February, that video will be available. Now, as for Microsoft, Satya Nadella's change in culture, Hasan just mentioned that, and that was on 2 sessions ago. A Microsoft manager in Japan, our alumni, HRD alumni, gave a talk here, and we have a 1-hour video of each of these sessions. So if I would encourage audience to watch these videos, these are also on YouTube, and I think that will help deepen your understanding of what Hasan was saying.
あるんですけども、こなせなさそうに
It's about the time. I had prepared some questions, but maybe we don't have enough time, so I'd like to share some information with you, make some announcements. Oh, by the way, HRD group regarding engineering organization, this is our first time to feature this topic. Today, I believe that Profile XT qualifiers or those who want to get a qualification are participating when it comes to DISC. This is a global solution, really. So for the Air Force, the U.S. Air Force page, using DISC profiles to understand airmen, they use this one, for example, dominance and so on. And Hasan-san belongs to Carnegie Mellon University, and human resources people use DISC. William Milestone started this, and everything DISC workplace will be provided by HR. That is what human resources of CMU is saying, and this is for professional development. There are all sorts of programs that are available, and we have a limited selection, but DISC is positioned in a very important way. So DISC facilitators, some of you are DISC facilitators and so on. So maybe your colleague is providing training to Hasan-san at the CMU. It is connected to a global community. And another announcement, HRD Next is an event. We have been running this series of events, and the next session will take place in January. From the 27th through 28th, we will have an event, so please participate if you have time. And DevSecOps Days Tokyo, this is something that I organize with Hasan-san. As I said earlier, for example, senior officials of METI will come, and Sairabo director and so forth will be coming as guest speakers. This one is for Space Command and Air Command Chief Software Officer. And Hasan-san and Dr. Linton will be coming as speakers. I will give a talk myself. I think they are still accepting applications, so do please come. By the way, today's session, the questionnaire or a survey, we have a survey, so please give your feedback to us, to panelists as well. There is a link to the survey on the chat function. Did you get it? So please respond to this survey. Okay, thank you very much. Now it's time to conclude. Well, actually, I wanted to ask a lot more questions, but I spoke too much, so we ran out of time. But I believe that we were able to have a robust discussion. So those of you from HR function, or those who want to digitalize an organization, I hope that we've been able to provide some inspirations for you to better your organization. So that's all for today. Thank you very much for coming.